What if you could print a solar panel like you do an image on a piece of paper? It sounds strange, but Australian scientists and engineers are doing just that. And their inspiration for this innovation comes from an unlikely source.
One of the CSIRO's most successful inventions is the polymer banknote technology. Once we demonstrated that we could print banknotes with high fidelity at high speed, the CSIRO asked the question of how do we use this skill set to create a new high-value product? And that's when we turned to solar cells. A flexible solar cell actually has 5 to 6 separate layers, so we print them one layer after another, one on top of the other. Each layer has a special ink which contains all of the special components which are needed to make the material perform correctly. Now, the techniques that we use are widely known and have been used for decades, if not centuries before.
And the big innovation here is roll-to-roll printing, a production technique that is quick and precise.
We have some layers which are as thin as 20 nanometers, but if there's any breaks or pinholes, the device will fail.
This is the latest field of research for photovoltaics, and one that departs from the solar cells you might already be familiar with.
The efficiency of conventional silicon solar cells at the moment is approximately 26 or 27%. This probably represents the limit that this technology can achieve. Now, we're working with a class of materials known as Perovskite solar cells, which on a small scale has achieved parity.
But they've only been in development for about 15 years.
So to reach this level of efficiency in this short period of time is absolutely unprecedented.
These new flexible printed solar cells are an innovation made possible by decades of research all around the world. The origins of solar power go way back to 1839, when a French physicist, Edmond Becquerel, first observes the photovoltaic effect. Selenium is the basis for some of the earliest designs. But solar electricity, as we know it today, comes from a breakthrough by Bell Labs in 1954.
The greatest innovation in solar technology is really the first steps that were taken when silicon was used to generate electricity. That laid the foundation for all the other materials that followed from there.
The early days of the space race are critical to accelerating the development of this new innovation.
Some of the earliest application for silicon solar cells were in space. It's an area where it's difficult to power a satellite.
Before solar cells, batteries only last weeks. But the first satellite to use solar power, Vanguard 1, lasts 6 years. But back on Earth, it isn't until the 1970s that solar power becomes efficient and cost-effective enough for practical use. As the cost of solar panels further declines, it puts the technology in the hands of more people. By the 90s, there's a huge shift to make it an everyday part of our lives. But just because the technology exists doesn't mean everybody's ready to take on the risk of being the first to use it, especially when you're putting up your own money.
Renewable energy is different to energy from fossil fuels, so we were prepared to pay a bit more for it.
We're getting all this renewable energy from the sun, and we get a lot of enjoyment when the sun comes out.
The cost of the original system, we were out of pocket about $5,000. Like, to put that into context, I think it was about 20% of our family budget for the year.
We were really keen to use the new technology, and we just were quite confident it was going to work.
Stuart and Wendy are the first in Victoria to install grid-connected solar panels on their home in Melbourne.
And any surplus goes through the meter, which runs backwards, and then across the wire to the street for other people to use.
And we knew, because it was the first in Victoria, that we were helping to pioneer it, and part of what we wanted to do was make as many people aware of it as we could, and that was why we did the open days and also tried to get media coverage at the time as well.
People were quite sceptical initially, and I think one of the biggest comments was, how long is that going to take to pay for itself? And we'd say, well, when you buy a new car, does it pay for itself? What else do you buy that has to pay for itself?
Their example brings the innovation home and shows how effective it can be as an alternative source of energy.
We weren't doing it for financial return, but it turned out we did get a financial return because it lasted so long and we ended up on the high tariff, but that wasn't the original aim. The original aim was to cut our greenhouse emissions.
Since those early adopters of the 90s, solar power generation has skyrocketed around the world. and the technology just keeps getting better and cheaper. Stuart and Wendy's original system lasts 23 years, but their current solar setup can generate more than 6 times the energy. The technology is so common now that you'll find solar panels on all sorts of buildings, including the museum. But that's not where you're likely to see these flexible printed solar cells anytime soon.
While we don't think that we'll replace silicon solar cells in the near term, we do think there'll be bespoke applications where it could be devices or portable applications where the power to weight ratio is at a premium.
And like the original creators of the silicon solar panels, they're turning their attention to space.
Space has very large temperature shifts and is also exposed to a lot of radiation. What we're hoping to achieve is a technology that can be more efficient in that environment.
The flexibility of these printed cells means that they could be rolled out in space, similar to what space agencies are already doing, but at a much cheaper cost. And their lightweight gives them another advantage on Earth.
We know we need to see solar technology deployed even more widely than ever. So we're hoping that this can be integrated into parts of people's lives where that hasn't been possible. So we know we're seeing a lot of enclosed cropping. That's due to the effects of climate change, where the planet's getting hotter and drier in some regions. However, these environments are difficult to power. With the lightweight flexible solar cells, we can put them on those structures without weighing them down and causing them to collapse.
And even if they don't fully replace conventional silicon solar panels, we still need to keep researching alternative technologies, and especially those that can complement our existing infrastructure, because our demand for energy is only increasing.
So the transition to renewable energy has to accelerate even faster, and we see this technology as being part of this energy mix.